My name is Cristina Dragan. I am a thermal analyst expert for Continental Automotive in Timișoara location. With the current presentation, I will try to answer to the question, why is the FEA simulation needed? How this can help our product development activities, and what are the main advantages from my point of view? Few words about myself. I am a mechanical engineer since 2010. I started to work for Continental Automotive in ADAS department as a mechanical designer, and since 2012 I switched my activity to thermal analysis. Currently I am working also on my PhD in thermal management domain. I have 5 patents and 3 published articles in thermal management domain. ADAS products are cameras, radars, and lidars. The main mounting positions in the vehicle are highlighted in these 2 pictures. We have the windshield in the rear mirror area, the side mirrors, the front bumper, and the rear bumper. The simulation workflow is simplified in this schematic. All the time we start from the goal of the analyze. After the goal is clear enough for the complete team, the FEA engineer starts building the model, continues with meshing, numeric model, and solving. After initial trustable simulation results are available, these are analyzed and together with the rest of the project team are decided the next steps. The end of the thermal simulation iterations is when all critical components are under the temperature limit and there is a technical available solution in the analyzed boundary conditions and in the cost limits of the product. One of the thermal analyses done in automotive industry is car environment conditions during an extreme summer day. This includes a solar radiation of 1000 watts per square meter, 45 degrees outside car ambient temperature, a reduced car speed, even 0 kilometers per hour is analyzed, and of course, with all surrounding parts like bracket, protection cover, and so on. For validation conditions at the high temperature analyzed in thermal chamber, there is in general no solar radiation, the ambient temperature is 85 degrees, and inside there is an unknown turbulent airflow behavior which varies from thermal chamber to thermal chamber. So the airspeed inside, it is unknown, and another difference is that we don't have surrounding parts. In the end, we should ensure that we are safe for both conditions. But we have to be aware that tests in car environment conditions are quite expensive. So, I ask myself, what can we do in order to increase the confidence level of the thermal simulation and decrease the cost for measurements? As the first step, I propose is to measure the air speed inside the planned to be used thermal chamber. The next step is prepare and perform a thermal simulation, a steady one, in thermal chamber conditions. Perform a thermal measurement in thermal chamber conditions, and if necessary, calibrate your thermal model for the measured airspeed inside the thermal chamber. After having calibrated the thermal model, perform a thermal simulation steady state for car environment conditions. If in car environment conditions any of the critical components might be thermally damaged, which means the internal temperature sensor might reach the softer threshold limits, a dynamic simulation is needed. If is needed, perform a thermal simulation dynamic one in car environment conditions. Here is an example of one of our ADAS windshield cameras analyzed in describe conditions. With blue bars, there are results in thermal chamber conditions, and with green, there are results in car environment conditions. You can see that some of the bottom components have similar values for both conditions. And for topside components, especially imager, we have a much higher temperature values, between 5 and 10 C degrees higher than what we have in thermal chamber conditions. This means that it is possible to pass TV and PV conditions in thermal chamber and fail real extreme summer conditions. This is the reason why it is necessary to perform also a car environment simulation, and this time a dynamic one. Here we have the results for a dynamic thermal simulation. The red horizontal lines represents the software threshold limits with the upper and the lower limits due to the tolerance of the internal temperature sensor. The blue line represents the internal temperature sensor, the dynamic behavior in thermal chamber conditions, and the green line represents the internal temperature sensor behavior in time for car environment conditions. The intersection with the lower limits shows that the camera might enter in protection mode. It depends, of course, by the tolerance of the internal temperature sensor. An intersection with the upper limit would mean that for sure the camera will enter in protection mode. So the intersection with the lower limit might end, depends by the tolerance of the temperature sensor. The intersection with upper limit, for sure camera will enter in protection mode. By looking to this graphic, we understand that we have 25 minutes available to change these extreme car environment conditions, like for example, to have a real car speed, like 30 kilometers per hour. So, why is the FEA simulation needed? This was the initial question of this presentation, and also which are the main advantages. The most known advantage is that we significantly save time and money by reducing the number of physical prototypes parts required in the good development of one product. Another reason why we need simulation is that you can check the effects of real-world extremes without having the real parts available, so much earlier in the development process. The technical advantage which I like the most is that you can calibrate your model based on conditions, based on existing measurements and known boundary conditions, and use these for other boundaries like car environment conditions. So you can calibrate your model based on thermal chamber conditions and use these for car environment conditions. Another advantage is that compared with the measurements, you can for sure change only one parameter and really count on the direction of improvement. During measurements, there is also environment noise, which influence in general the results quite a lot. This is the end of my presentation. Thank you for your attention.